Good morning, everyone. Ladies and gentlemen, esteemed participants, and distinguished guests. Welcome to this highly anticipated webinar on cloud data computing. Welcome to this highly anticipated webinar on cloud data analytics, a topic that is at the forefront of today's rapidly evolving technological landscape. We are truly honored to have with us today a luminary in this field, someone whose expertise and insights have made a profound impact on the world of data analytics and cloud computing. Our distinguished chief guest for today's event is Mr. Rohit Pawar sir, a visionary leader who needs no introduction in dream of cloud data analytics. Sir has a remarkable career during which they have spearheaded groundbreaking initiatives pioneering the use of cloud technologies to extract valuable insights from data, enabling businesses and organizations to make data-driven decisions in real time. Sir has over 7 years of experience in data engineering, proficient in PySpark, Python, SQL, Azure, Snowflake, and open source tools. Solved diverse business problems across verticals, including supply chain analytics, transportation optimization, media enrichment, lead generation, SKU organization, and data modernization. Expensive exposure to Databricks, Azure, and Spark's ecosystem with a focus on building scalable and optimized data platforms. Major experience in optimization and performance tuning on Databricks and Snowflake. Built graph-based frameworks using Neo4j and GraphFrame on Databricks to solve multiple business problems. Proficient in building pipelines for structured, semi-structured, and unstructured data formats. Implemented JSON data converter to structured data model in Python and Spark. Successfully solved NP hard problems in the transportation industry related to bus and crew optimization, migrated multiple customer legacy systems to cloud ecosystems efficiently, and delivered 10 plus projects with Databricks as a processing layer. His certifications include Partner Solution Architect Essential, Databricks Certified Associate, Developer, Apache Spark, Databricks Certified Data Engineer, Azure Certified Data Engineer, IBM Cloud Developer, Microsoft Certified Professional, Microsoft Technology Associate, IBM Big Data Engineer, and many more. Mr. Rohit Pawar sir is currently working at Fractal Analytics Pune, where they continue to shape the future of data analytics in the cloud. With their wealth of knowledge and experience, they have been instrumental in driving innovation, fostering collaboration, and helping organizations harness the full potential of their data. But beyond the impressive professional achievements, Sir is a true thought leader in the field, a mentor, and an inspiration to many. They have been actively involved in knowledge sharing, contributing to the community, and nurturing the next generation of data professionals. Today, Mr. Rohit Pawar sir joins us to share the invaluable insights, experiences, and visions for the future of cloud data analytics. We are fortunate to have the opportunity to learn from their expertise and gain a deeper understanding on the challenges and opportunities that lie ahead in this dynamic field. Now, I would like to ask Sir to share valuable insights on cloud data analytics. Over to you, sir.
Thanks, Yashasvi, for this fantastic introduction. So, first of all, I'm thankful to, you can say, Dr. Prashant Javade sir for, you can say, setting up this time with you guys. And I'm very fortunate that, like, I'm here, at, like, in front of you. And thanks to you guys, right, like, for your sacrifices today. I guess, like, today is holiday, but still you guys are here with full of, and say, I guess, like, 60 members are here, right? So, I can see, right, like, that enthusiasm, and then uh, it shows basically, right, like, the positiveness, and then confidence, and then you can say it like your career oriented guys, right? So first of all, thanks for that. Without wasting time, right, I will just share my screen. Let me know once my screen is visible, and then we can get started with the today's agenda. Let me know once my screen is up.
Yes, sir, it's visible.
Okay, perfect. So you can see my presentation now, right?
Yes.
Okay, great. Okay, so today's topic is basically, right, like the cloud data analytics thing, right? So if you see, right, like currently the data market is growing very rapidly, right? Prior to 2010, right, like data quantum was very less, and the processing systems, right, also was very limited. uh, in 2010, prior to 2010, I would say, right, like there were systems, right, like the commodity hardwares we used to use, and then we write the, you can say, code in C++ or like Java, and then process it on our own data center, right? Due to this cloud shift, basically what happened, uh, I guess, due to this cloud generation, right, like whatever new thing that came in picture, right, like it is giving good chance actually, right, like rather than procuring the hardwares or commodity system by our own in the data center, you can say leverage the capability of the cloud and provision the services as and when you need it, right? So today's topic, I you can say that, like, decided because this is a need, and I am seeing that, like, there is very limited knowledge base in the current market, and there is more surge in the, you can say that, the requirement as considered, right? Prior to 2015, kind of sorted, like you can say that, like, everyone want to be, you can say, like, Java developer or C++ developer, or like you can say .NET developer. Now that particular paradigm has been shifted from, you can say, like, that particular development based to the data career focus system, right? So that's why I choose like data analytics, but rather than just selecting a data analytics, I just added the additional flavor to it, saying that, like, cloud data analytics. So these are the, you can say, three pillars, I would say. First one is a cloud, second one is a data, and then ultimately, like creating the analytics on top of it, right? So this is what actually Yashasvi already, like, given the details about me, right? Like what I am. I will not go much deeper in this now, and I will just go to the agenda. So today, basically, right, like we will cover these many topics. So first one is definitely, right, like what is cloud computing, what is data, then what is analytics, right? Because these are the main pillars that I said, right? Now how all of this, right, like can be built and like connect to each other, right? Like these are the dots, I would say, right? Like cloud is another dot, data is, you can say, right, like another pillar, and then analytics is ultimately one thing where you can say, right, like you need to build particular reporting to the C-suite customer, right, like basis that they can take a decisions on top of the data that they have in-house or like third-party data system, right? So how that things can be connected, that is another pillar. Now, what actually, right, like cloud solves in perspective to the data analytics, because prior to cloud, there is also, right, like data analytics user or like developers used to do analytics on top of Excel sheets, right? Like they used to write the regression model on the Excel sheet. They used to write, you can say, SAS-based models. Someone using, like, you can say, MATLAB as a programming language, right? So how that actually changed with the, you can say, evolution of the cloud. So we will discuss on that part as well. As part of career concern, because I'm majorly, right, like focusing towards how you guys can, you can say, enter into this particular field, right, like rather than, you can say, giving the knowledge like what and all, because it is huge field. We cannot cover all these topics in, you can say, 2 hours or like 1.5 hour, but what topics actually you guys should focus on it, like so you can smoothly move in that particular career path and then get, you can say, good opportunity in the sector, right? Then I will show that like how the architectures are been built on the cloud with respect to your data product concerns. And then ultimately, right, like whenever we actually take a cloud data related, you can say, activities, right, like 80 to 90% work is basically on the processing system, because you have a data, right? So suppose there could be plenty of the data sources, right, like coming from the different systems, right? It could be SAP, which is like one of the ERP system, right? It could be, you can say, other CRM systems, right? So you pull that data, but ultimately, right, like after pulling that data, you need to build some, you can say, right, like analysis on top of it, right? Like to do that, there should be, you can say, some, you can say, business rules or like, you can say, logic that you need to enforce on that particular data set, right? Like which is actually we consider as like processing layer, right? So for that processing system, ultimately you need to select right strategy and like right compute power sources, right? So how that can be selected, that we will discuss. I will give some live demo and then one assignment to you guys, right, like which you can send it to me like on my mail. I will take some question and answers at the end, and then we'll share my contact details. So let's dive into, you can say, like first topic, which is like, you can say, cloud computing. So how many of you have heard about cloud computing or like worked on the cloud earlier? So I guess like you are all are like from the last year students, right? If I'm not wrong. Okay. So you know about, you can say, what is cloud, right? So I will give, you can say, brief idea what cloud is and like why actually cloud came in the picture, right? So cloud computing is nothing but actually it is a system, right, or like service which basically gives the capability to the end users, or like it could be, you can say, developers, it could be anyone, right, who are actually building their software suite, right? So it gives the chance to that end user rather than procuring the hardwares on their own, right? They can get the particular services on the fly on the, you can say, cloud, and it is a pay as you go model, right? So that means whatever you use, you just pay for that, right? So what happened earlier, right? Like when cloud computing was not there, right? So there were a couple of challenges that I saw, and we also encountered that in my prior organizations, right? So suppose, right, like I need to build some, we can say, some particular data analytics platform, right? So first step is basically, right, like I need to procure the hardwares, which is, you can say, GPU enabled systems or like CPU enabled with higher computation power, right? So that is first thing. Now, second one, I need a data center where, because if that particular server is I'm procuring, right, like ultimately it needs cooling power, right? So for that, we need to maintain room temperatures and everything, right, like with the proper system. So their infrastructure we are utilizing by our own, right? The networking switches, routers, everything we need to configure by our own, right? So all these aspects actually we need to handle by our own, right? Once we set up all this ecosystem, we will code it, we will write the code, we will do analytics, we will create a reporting, we will write, you can say, like machine learning models or deep learning model on top of it. We will publish that particular, you can say, that like endpoint, so that like front end application can consume that particular you can say model, or you can say that particular weights from the machine learning system, right? So if you see, right, like in this space, the hardwares that we are actually procuring or like we are building by our own, right, need a maintenance. So there will be maintenance window always, right? Like every month there will be, you can say, right, like some 2 hours or like 4 hours window where support team comes in picture and they will basically, right, like do a maintenance, patching activity and everything. So what that patching means, basically, whenever you procure any hardware or you can say like you install some, you can say operating system on top of it, right? Each and every operating system will have like their own patches in the sense, suppose today I'm using, you can say like Windows 10, let's consider, right? And then there is Windows 11 came in picture, right? But the Windows 11 could have, you can say, some issues inside to it, right? So we need to fix that issues. Otherwise, right, like it will harm in perspective to the security practices, right? So all of this thing actually, security team need to be monitored and they need to fix those patches, right? Now it is a, we can say, overburden, right? Like where we need to onboard 24/7 support team who will basically totally work on, you can say, the maintenance activity, right, of the infrastructure, and then they will keep that particular system up and running for 24/7, right? So it is extra cost, there is extra maintenance, there is extra, you can say, right, infrastructure that we need, right? So all of this thing concern what Microsoft, AWS and GCP, right, like these are the bigger cloud players currently in the market. IBM is also, right, like currently one of the, you can say, good player, but most of the, you can say, project that I see, right, like are currently running on the Azure ecosystem, a little bit on, you can say, AWS, and some are currently on the GCP cloud, right? There is Oracle cloud also available. There is Hawaii, right, is one of the, you can say, company, right, like they have also their own cloud. So there are multiple cloud players, but you can say that like we'll restrict to, you can say, some three bigger cloud players today, right? Now what they decided actually, right, like rather than, you can say, procuring your hardwares, what you can do is basically you just say that like what resources that you need, right? And then we will provision that particular resources for you, right? Now what these players actually did, they created their own data centers in multiple locations, right? So they have around all the countries, right, like in the ocean regions, right? Like they created their own data center. As I mentioned, right, whenever you create a data center, ultimately it needs cooling power, right? Like you need to maintain a room temperature and everything, right? For this, what these players did actually, rather than again investing on the electricity, right, like to reduce the power, or you can say, right, like the heating systems, right, like on the servers, they directly dump that particular data center under the ocean, because ocean is always, you can say, cool, and then all the, you can say, systems will be, you can say, right, like cooler, with the encapsulation of the, you can say, right, like your hardwares, everything, right, like will get encapsulated in one of the body, and then that body basically, right, like that they will put on the, you can say, right, like ocean. So where they reduce the costing with respect to infrastructure, right, like the power consumption kind of sort, right? Now from that particular data centers, whenever you request something, right, like suppose I want server, right, like suppose XYZ server with particular configuration, I will just say that like I want, you can say, right, like 12 gigs machine with this configuration where it has, you can say, Ubuntu operating system. It will basically procure, it will hit to that particular data center and it will provision that resource for me, right? So it is totally simple. Now in this case, right, like maintenance, no need to worry, right? Because everything will be managed by that particular cloud vendor. No support team, nothing, right? So all things will be managed by the cloud providers, right? So that is basically your cloud computing, where actually, right, like it is removing the dependency from the actual engineering team on the infrastructure or the services, right? So that is pretty much about, you can say, cloud computing. Now what are the key characteristics about it, right? As I mentioned, it is on demand. You can, right, like get it as and when you need it, right? And second one is, you can say, right, like it has like broad network access, right? Like so you can connect from India to, you can say, East US or like West US, anywhere, right? You can connect with mobile phone as well. We can connect with, you can say, right, like any of the device, so there is no restrictions at all, right? So they have created all routers, switches, all the, you can say, networking configuration in the proper way with subnets and, you can say, virtual networks, right? So all things are managed in the proper way. Resource pooling means, you can say it like multiple customers. So it is not just, you can say, for practical, let's consider, right? So it is not just for practical, it is for everyone, right? So who can, you can say, be part of that cloud platform journey, right? So anyone can, you can say, procure the hardwares or, you can say, services. So it will automatically, you can say, that like shift that particular resources from one person to another person in the, you can say, scalable way, right? Elasticity is another pillar. So I forgot to tell about, you can say, one instances where we asked for, you can say, procurement of the hardware, like to one of the company, and we got, you can say, hardware for, you can say, 6 GB of the machine. And when we ran our algorithm actually, right, like it took more than more than 12 hours on that, right? Because it was, you can say, right, like doing some epochs inside to it and then retraining the systems, right? Uh, and then we observe that, like, because it is not a GPU enabled system, it is taking much more time, right? It was, you can say, Kira's model ultimately. So in that case, right, like we need to again onboard another machine, right, which is a GPU enabled machine. Now, if you see, right, like that earlier 56 GB machine, right, like whatever CPU machine is not of use, right, like it will be as is like ideal in the, you can say, data center. Now, that is not a case in the cloud. So if suppose today you say that, like, I want, you can say, GPU enabled system and I don't want, you can say, CPU based system, right? You can just decommission that particular system and you can move to the another GPU enabled system. So it is totally, you can say, fine that you can decommission any resource at any time and then you can provision another resource at anytime, right? So it is a elasticity. You can change your scale from 1 to 2 or like whatever x that you want to do, right? And it is metered in the sense that, like, it is not like that, like once you procure it, like it will be cost for whole month. It is, you can say, if suppose you are using it just for 1 hour, it will be, you can say, charged for only one hour, right? So that is the benefit of the cloud computing. Now, if I just go to the, you can say, different service model, right? So these are the different services that you can say, right, like cloud computing provide, which is nothing but what are the different type of OSS system layer it basically operates in, right? So I guess, like, you might have heard about, there are two types of, you can say, network architecture, right? Like OSS model and then there's TCP/IP model, right? So this works basically in similar way, right? Where infrastructure as a service is just, you can say, you will get infrastructure like virtual machines or like servers or networks, and you do everything by your own, right? So patching, everything you need to do by your own, right? So it is maintainability is with you. Platform as a service is basically, right, like patching activity you need not to worry about. You just code and then deploy your code on your system, right? So there are, you can say, some of the systems or like services that Azure provide, like app service plan, right, which basically totally managed by Microsoft. You just have to code and like put that code in the, you can say, app service plan. It will automatically boot up the application on the front end. There is software as a service, right, which is basically like Databricks. It is one of the, you can say, biggest SaaS platform, or like Snowflake, where you need not to worry about like what is the underlying infrastructure, what is the networking setup, right? And then you need not to worry about deploying code as well, right? So you just use that particular platform to curate or like transform your data and then like do your data analytics, right? That is another example for the software as a service. And then next one is, you can say, like function as a service, which is a serverless computing. So most of the times we see that we need to write a code, right, like in such a way that like it should be event based trigger. Like if suppose, right, like there are requests coming from some HTTP endpoint, right? So it is a HTTP trigger function, right? So that means if suppose I hit particular, can say, right, like endpoint, then it should trigger this particular flow and then automatically that process should complete, right? There is another type of, you can say, event based trigger is like time trigger. So suppose you have written a code and then you want to process that particular code base every 5 minutes, right? Which is a time trigger. That means most of the times when we create it by, you can say, right, like our own on-premise system, right, we write our cron jobs, right, like to handle all these things, or like batch processing systems. But with respect to, you can say, event-based systems on the, you can say, cloud, right, it gives capability, right, like no need to write any scheduler or anything, right? It will handle by your own, and then every 5 minutes it will trigger and then your code will get run. It will load that output to wherever you want to arrive to, right? So that is the concept of, you can say, this type of service model. Now, next one is definitely a data, right? So first pillar that we covered is cloud. Second one is like data, right? So cloud data analytics, right? So what is data? So data as per se, right, like will not have any meaning. So you have like plenty of data, but without, you can say, creating or like as formulating the information on top of it, right? There is nothing, right, like that you can derive. So data is always unprocessed and it is raw, right? So you need to process it, you need to create information on top of it, you need to connect the dots and then get the, you can say, insights, right? So when we talk about data, right, there is another concept comes in picture, which is a big data, right? So big data is basically, right, like if you see digitalization is happening, right, very rapidly. So earlier, right, like as I mentioned earlier, we used to, you can say, create a regression model or any, you can say, type of, you can say, analytics on the Excel sheet, because Excel sheet is capable to handle 1 million records at a time, right? And earlier, right, like the quantum of the volume or quantum of the data is not that much heavy, right? So we used to, you can say, write all the logic, everything, right, like the Excel sheet. Now what happened, right? Like this data is growing very rapidly. Everyone has smartphones. Everyone is, you can say, right, like using WhatsApp. So you can take example of the WhatsApp, right? Like daily you are sending messages here and there. It is totally, you can say, unstructured kind of data, right? So you need to create a NLP like model, right, which is a natural language processing system on top of it. It is not a structured like Excel sheet or like CSV kind of sort, right? So it is a little bit unstructured kind of data, but it is growing very rapidly, right? Your call details, it is also one of the, you can say, unstructured data type, which is also growing very rapidly, right? So due to this rapid change in the, you can say, data, right, we need actually, right, like big data ecosystem, right, like which can process the systems in the, you can say, faster way, rather than, you can say, scheduling the jobs on Excel sheet as a VBA and then, you can say, give that, or like micro, right, and then give the output, right? So it is not possible now. So for that, we got the concept saying that like it is a big data, right? So when big data came in picture, basically you need to think about how that big data can be processed, right? So for processing that big data, there are multiple, you can say, right, like ecosystem that got built, right, like from the Apache Foundation majorly. You might have heard about Hadoop and Spark, right? So prior to 2012, right? So Hadoop was very, you can say, right, like rapidly in use, right? Now it is totally shifted that paradigm to, you can say, Spark as a, you can say, computing engine, right? Because Spark is basically your on memory kind of, you can say, processing system, right? And Hadoop is a little bit different than that, right? So these are the systems came in picture, right? Now when big data came in picture, basically there are ultimately a 5V concept that like came in picture, which is how the volume looks like, right? So first V is basically your volume. So what is the volume of your data set, right? So basis on that we judge, right, whether it is a big data or like which can be handled on like normal single node machine, right? So that is first thing. Second one is variety, right? So your, as I mentioned, right, like the data systems are dispersed. So one is, you can say, phone calls, another one could be, you can say, messages, another could be your email records, another could be, you can say, you're maintaining some Excel sheets for the attendance, that could be, you can say, another data. So all of these things, right, like are the variety of the data systems, right? So for processing that thing you need to write different logics, right? So that is a variety of data. Value is another pillar, right, which basically says that what particular insights that you can get it from your, you can say, whatever data that you have, right, like, or whatever big data that you have, right? So that value is nothing but how that insights can help my business to grow in the, you can say, future, right? Or how I can compete to my competitors, right? So all of these things need to be, you can say, validated. Now next is veracity, right? And then another one is, you can say, velocity. Velocity is basically, right, how rapidly your data is coming. So prior to, you can say, right, like this digitalization world, right, your data was coming very slowly, right? Because there were very limited resources, very limited networking, right? And then we used to, you can say, send messages very rarely, right? Now it is, you can say, like very rapid. So you will chat, right, like with your friends here and there, right? So this data flow is basically increased in very fast pace, right? So that is your velocity. So all of these 5 V's actually we need to take care of, right? Like when we concern about, you can say, data system, right? Now, as I mentioned, right, like there are different types of data structures, right? So structured data systems, under unstructured, and then semi-structured, right? So structured is basically, right, like which you can read and immediately, you can say, understand. So Excel sheets, CSV, right? So these are the structured data sets or database systems, which is your RDBMS system, right? Like relational databases. So these all are systems are your structured data. There is unstructured concept, right, where you will get images, videos, documents, then your text files, or you can say the messages that I mentioned, right, like your social media post and everything. So these need to be passed in a little bit differently. So while processing unstructured data, it is a little bit different because if you say, right, like if I want to get insights from the CSV file, right, like it is pretty much simple because you can read that in the pandas and then you can get the insight on top of it, right? You can do EDA and then get the details, right? But with respect to unstructured, you need to pass the PDF file. You need to get that particular table from some X number of page, right? So it could be on 10 number page, right? You need to pass that particular table, get that details, and then create a table on top of it and then process it, right? So it is a little bit different, or it could be another way, right? You need to parse that particular PDF totally and then get the semantics out of it, saying that what actually, right, like this PDF refers to, what is the abstract, right? Like why this PDF of 10 pages, pages has been written and what is the abstract between it, right? So generally, right, like when you guys publish the paper, you write the abstract and then keywords, right? So that abstract can be, you can say, derived from this type of unstructured data processing system. There is another pillar which is like semi-structured data where you have like JSON structure or like XML structure, which is not pretty much a structured data system, but it can be understood by you in simple way, right? So JSON you can read and then you can understand like easily because it has like key value kind of pairs. Then the next thing is like how this data get, you can say, entered. So as I mentioned, right, like your data comes here, right? So which is like totally unprocessed and like raw system. Then basically, right, like your information, right? So basically, right, like what your enriched data, right? So input data, suppose let's you get the input data, right? And on top of that, you are getting some insight, right? Like which is your information. So you are saying that like this is my abstract, right? Like this person is saying about this thing, he's messaging to this person, right? Like about this part. So this is information, right? Then on top of that, it comes knowledge, right? So which is a semantic layer, right? So you create some knowledge base saying that like why this message happened, right? Like why they are chatting between, you can say, right, like between, you can say, on this particular topic, right? Or why this particular person has sent this particular mail to another person, right? So all of this thing can be, you can say, calculated as part of knowledge base, right? Once you get a knowledge, you need to take a decisions. So that comes at the last layer, right? Where you say that like this is on this particular knowledge, I will say that this is my decision, and then this will basically help to, you can say, right, like track down the problem, or like you can say to, you can say, resolve this particular issue, right? Most of the times, right, like when we see that without knowledge decision cannot be taken, right? So if you see, right, like the consumption layers are always reporting layers. So there are C-suites customer, right? Like C-suites customer are nothing but, you can say, CTO, CEO, or like higher level organization levels, leaderships, right? So they take a decision based on knowledge. So suppose, right, like my revenue is getting reduced, right? My revenue is not up to the mark. So what particular measures that I should take, right? So if suppose I am giving some knowledge to them saying that these are the particular numbers, right? Like these are the employee counts, this is my billing rate, and currently this particular percentage of the employees are not billable. So they will get idea saying that like particular 30% employees are currently on bench and then they don't have any project, right? That means we need to, you can say, pull the pipeline and then give the project to this particular you can say team member, then only my, you can say, revenue will jump up, right? So all of this thing need to be derived based on the knowledge. So this is how actually it get enriched. Next, it is analytics. Okay. So once you have cloud, you have data, ultimately you need to build the analytics on top of it, right? Which is your insights, right? You find some patterns. Now take an example, right? Suppose I am purchasing something, or like I'm doing some transaction every 5th of the month, right, on the SBI. Now SBI has that data, right? But they have not created any analytics on top of it, right? Now what particular analytics can be performed, right? So one could be, suppose I'm performing transaction every 5th of the month, right? That means we can build a recommendation system which basically says that if suppose, right, like I am the person, right, so automatically on 4th of the every month, right, like it will give a message to me saying that like your purchase, or like you can say due date of this particular thing is on 5th, and then you just do a transaction on this day, right? Like it is a reminder kind of systems, right? So for that reminder system, ultimately you need to understand what is the pattern, right? You cannot send blind reminder, right, like to anyone, because if suppose I am doing transaction on 5th, it could be different for another person, right? So I need to find the pattern for each person and then behave in that particular way, right? So that particular pattern finding, or like insights finding, right, is one of the crucial part from the data, right? Ultimately it should be anonymized. You cannot say that like Rohit Pawar, this is account number, and then he is doing transaction on this. No, we have to restrict the all the, you can say, guidelines of the compliance. You cannot push the, you can say, name, or you can say their account number anywhere, right? Because it is complementary data. You cannot share that details to any other third party, right? So all these things need to be, you can say, managed. So when we come to the analytics, right, like there are some things, right, like that we need to take in consideration, right? Ultimately, first one is data collection, where you need to collect the data from different diverse systems, right? It will not be like you will have like data on the, you can say, your storage account or your databases, and you need to process that data. It is not like that. You need to first procure that data, load that data to your systems, and then start working on that, right? Second one, cleaning. Ultimately, you need to clean that data. There could be, you can say, some garbage values or like blank values. You need to you can say it like clean that particular data system. You need to do a exploratory data analysis, which is basically uh, m- more detailed report, right? So which basically says that like how the patterns are looking like between the each and every parameters, right? Like so generally when we talk about, we plot the graphs in like multi-dimensional views, or you can say a two-dimensional view, right? And then we see like how the patterns look like, right? Where so suppose there could be chance that x and y are the, you can say, your two pillars, and then you are checking, right, like how the pointers are looking like, where it is basically like all the pointers are basically gathered at one point, right? How the you can say that like distribution is happening here, whether it is normal distribution or it is uniform distribution, right? So all these things actually need to be calculated as part of exploratory data analysis. Then it comes, you can say, statistical analysis, which I just mentioned, right? Like your numerical systems, right? Like your hypothesis testing and everything need to be done on the statistical layer. Machine learning, probably you guys might have heard about this. You guys are, I guess, like working on that regression, classification, clustering, and everything, right? Like need to be considered, like need feature engineering, right? So for that feature engineering, you need to build that particular features. Then and then only you can say apply the, you can say, machine learning on particular target column, right? So suppose I want to predict house rate, or like house, what could be the, you can say, price of particular house, right? What would be the parameter that I need to think of? First one, definitely, what is the carpet area, right? In which area it is located, whether it is a Pune or whether it is Ahmednagar or it could be Nagpur, right? The prices are vary between, you can say, like all these different places, right? So these are my features. So you need to create that feature engineering first before you can say go into the machine learning model. Next one is your data visualizations, where basically you build a reporting which basically gives more insights to, you can say it, like your end users, how the patterns are behaving, right? Then there is, you can say, business intelligence, right, where you build some KPIs which are nothing but key performance indicators, right? Like what is the revenue, right? So it is just a single number, right? Like it could be like $10 or it could be $20, right? So all these things you need to build as part of business intelligence. There is preventive and prescriptive. Preventive means, right, like before happening, and then prescriptive means once it happened, right, like what particular measure that you can take, right, like on top of it. So all of this thing comes under your machine learning semantic, you can say, modeling part, right? Real time analytics is another part where you will not always have data in the, you can say, batch mode, right? So there is concept of the operating system, I guess, like you might have heard, or like you might have learned in your engineering, right? It's like in the second year or third year, there are types of operating system, right? The real time operating systems, and then batch operating system, right? So batch operating system is nothing but at particular time interval, right, you will perform some job, right? So that is your batch processing system. Real time operating system is basically, right, like whenever you get a data, immediately you need to process that data, right? So if I take an example, right, like recently the Chandrayaan 3 got launched, right? So suppose it got launched, and if my program is, you can say, right, like behaving in different way, right, like in the batch mode. Suppose today it launched and then it is giving me data tomorrow, right? Which is not right, right? Which, because there is a delay. We need that particular data immediately, right? It should be managed immediately. Another example could be, you can say, nuclear power plant. So you have nuclear power plant data which is coming from the different sensors, and then you need to monitor the temperatures, right, like whether it is proper or not. And then suppose, right, like if there is a fluctuation in the temperature, you need to immediately alert that to the system. But you created a batch processing system, right? So rather than real time analytics, you given the, you can say, batch mode kind of, you can say, output, right? Which is wrong, because it will harm to that particular, you can say, nuclear power plant, right? So all of this thing need to be considered as part of real time analytics. Then there is a big data analytics, which I just talked about, like it could be Hadoop or like Spark. And then definitely a privacy and then ethics, right? Which is nothing but how your, you can say, like data can be compliant, right? Because there is compliance rules for every country, so you cannot share the confidential data, or you can say, like the PII information. So generally we say that personal identifier information, right, which is PII. So suppose my name, my address, my ATM card number, my bank account number, right? So all of these are my personal identifiers, right? I cannot share those details to anyone, right? So that particular data also we need to manage in the proper way with hashing technology. So we mask that data rather than, you can say, deleting that particular record, right? Now we learned about like what is cloud, what is data, what is analytics, right? Now how this all pillars can be connected to each other, right? So that is another part. So first and foremost thing is basically, right, selecting the right cloud provider, right? So it could be, you can say, AWS, Azure, or GCP, right? Once you select that, you need to create an architecture in the scalable way, which basically says that to solve that particular problem statement, what and all services that I need, because AWS has around 200 plus services in into it, right? Azure has around 2000 plus services, right? So selecting limited resources, or you can say particular services, is a crucial part, right? So you cannot select all 2000 services and then connect these to each other, right? No. So for data centric application, you can say that like I will select 10 services, which will basically solve my this problem, right? So selecting that particular right infrastructure, right services is crucial. Second one, ingest that particular data. So as I mentioned, right, so suppose I want to build an application for, you can say, supply chain analytics. Let's take an example for supply chain, right? So supply chain analytics is nothing but where there is a production unit, right? So suppose I am a producer and I'm producing some biscuit packet, right? So I'm creating that biscuit packet at particular location, right? Now that particular pouch I need to send to the inventory, right? From that inventory it will get distributed to the distributor. From that distributor it will go to the, you can say it like yours, you can say suppliers, and from there you will get to your home, right? So all of this is chain, right? Now let's consider like what actually supply chain analytics means. Suppose my particular plant for the production is in Delhi, okay, and whatever packet that I am producing, it has high surge of demand from Pune, right? Now what is happening here is I have plant in Delhi and my requests are coming from the Pune majorly, right? Like for that particular product. Now I am unnecessarily wasting my transportation cost, which is right like from Delhi to Pune, right? So rather than that, I can take a decision saying that ultimately, right, like it should be, you can say, prior to giving the, or like putting the plant right at particular location, definitely we should do a market analysis. But surprisingly, right, like they haven't done that, and then suppose they came with this scenario, right? So you have to, you can say, build the plant at such location where your transit time is very limited, right? So that is first thing, crucial part. So all of these things need to be managed, right? So for this particular data, right, I need to insert what is the my inventory, what is my production, how much quantity that I am producing for that particular stock keeping unit. So we generally see the barcode, right? Whenever you go to the DMart or like any shop, right, you will get the product barcode. So that barcode is nothing but the unique identification. We generally call it as like SKU. It is a stock keeping unit. So it is a unique, right? So we have to manage that, like for that particular SKU, right, or like for that particular packet, what is my inventory, how much inventory that I have, what is the production that I have, what is the supply that I'm doing, right, like, and what is the demand that I'm getting with, right? So all of these data points are coming from different data systems, right? One could be, you can say, from ERP, some could be, you can say, some own applications, some could be from Shopify, or you can say e-commerce website like Amazon or like Flipkart, right? So all of these data systems need to be ingested, so that is an important part. Now integration is basically, right, like you create a ingestion, but ultimately on top of that you need to write a transformations and like load logic, right? So you transform that data in the proper way, right? Like because you will not get data always in the, you can say, structured way, right? It could be, you can say, other way around, right? So you will have like JSON structure, you will have like PDF data. All of these data points need to be connected to each other, right? Like to get the proper insights, right? Then analytical service, which I mentioned, right? So you need to select right analytical service, right? Like suppose you are doing machine learning, then which particular machine learning service that you will use, right? That you need to decide based on what type of workload that you know. Then data preparation transformation is another part where you need to enforce some of the business rules, whatever that you can say it, like end user or like whatever product or like project that you are dealing with the customer, right? They will have their own business logic. You need to enforce that on top of your data system, right? Then machine learning. Once you have like machine learning, what type of regression, whether you will do a regression classifications or clustering, or you will go with a deep learning kind of model, right? Or you can choose a open AI as well, right? So that particular system you need to decide. Then data visualizations, where you will say that like for this particular problem statement, I will go for, you can say, Power BI, or I will go for, you can say, Tableau, right? So these are the reporting tools where you will say that once I have data properly cooked up, and then I transform that data or curated that data, I will load that to the, you can say it like one of the warehouse. From that warehouse, actually it will go to the Power BI consumption layer, and it will showcase on that reporting, right, like on top of that layer. Now till point number 7, right, it is end of your development, but after to point number 7, right, it is basically the improvisation, right? So once you build the system, it will not be 100% correct, right? Because you may see the challenges in the system, right? So you need to overcome the challenges. You need to optimize that system. That is another point, right? Where you need to scale, optimize the system. So where you it may happen that like I will give example, right? So when I work with one of the company, right, and then we created a database cluster for like two nodes. So it is like two machines. Each machine has like 112 gigs of RAM inside to it, and one driver, right, which has like 256 GB, right? So there are total three machines that we created for the you can say data processing system. Daily we were getting around 450 GB data, which we were inserting in the our data storage. Our data storage was around like 40 terabytes plus data system. And when we created this ecosystem earlier, right, like it was properly behaving in the way, right? It was taking like 5 hours or like 6 hours to process, load that particular data and give the reporting, everything, right? But when the data system increased, right, we found that issue saying that like our cluster was getting terminated, or we can say jobs were getting failed, right? It was giving some out of memory issues, right? We changed that cluster. We you can say right like did optimization on the code as well. It was taking around 22 hours at the latter point when it was getting filled, and then we cut down that to the 2 hours again, right? So that particular reduction, right, like from 22 hours to 2 hours, right, is a crucial part. So you cannot say that like it will grow always. So it will be 5 hours today, it will grow to 22, and then it will grow to 40. No, it will be optimized. It should be optimized. So whatever code that you will write, whatever infrastructure that you will set up, everything need to be, you can say it like properly managed and then optimized, right? So you need to take that as well in the consideration. Then compliance security, which I mentioned, right? Like your PII handling and everything need to you can say manage. Data governance is basically right, like you need to uh, uh, get you can say right like all the data compliant with the particular data system, right? So each and every pillar of the data has their own compliance. So suppose there is a finance, right? So they have PCI compliance. If you are going with you can say right like healthcare data system, they have HIPAA compliance, right? So all of these are the certifications basically, right? Like how the data has been managed in the ecosystem, right? So all these things need to be you can say monitored and you can say managed in the you can say ETL transformation layer, or you can say your machine learning pipeline, everything, right? And then continuous improvement, whatever I said, training and skill development is crucial part, because whatever new team member comes in place, right, like they need to you can say groom and then develop their skills on this particular technology so that like they can efficiently work on this particular cloud data analytics part. Now, this I covered, I guess, earlier, right? But I will just go through quickly here, right? Like what particular things that like that data analytics solves for, you can say, on the cloud, right? So there is very high SLA, which is like service level agreement is 99.99%. So your services will not go down anytime, right? So it will be up for 24/7. There is no maintenance. You just focus on your code, no infrastructure, no not needed. You need not to worry about what infrastructure that is running behind the scene. 24 by support team on the infrastructure, no needed, because all infrastructure management will be done by you can say cloud vendor. No patching activity, nothing related to the security, because all data will be you can say secure in transit as well, and in the you can say right like at rest as well, right? So whatever data you have in the storage account, that will also be kept as like secure, and then whatever data is moving between the systems, right, is also be secured via proper tunnel, or you can say right, like proper networking and like firewall setting, right? So that you need not to worry about. Easy PI and PHI handling, which is basically right, like same thing which I mentioned, personal identifier information and then your healthcare related information. You cannot publish to the outside world. That need to be handled in the proper way, right? There are many configuration which I mentioned where legacy system, right? Like if I go with our own data center, we have to actually procure our own resources and then we need to change it based on our needs, right? But it is easy in the you can say cloud systems where you can procure and then you can decommission, you can provision another resources, right? So you have many configuration options. Many processing systems, you have very too much, you can say, right? Like I would say like SaaS products like Databricks, there is Snowflake. These are the powerful, you can say like data processing system. BigQuery is another, I can say, player in the market. More serverless computation and easy integration. So these are the things basically, right? Like basically makes easy for the data professional, right? Like to work on the data, create insights rather than like looking for what infrastructure is giving you. Now this is the important part for you guys, right? So intentionally I kept this part because if suppose that like out of you 60 members, right, like if you guys are looking for doing the career in data sector, right, then probably these are the topics that you need to learn on. Probably right, like everyone will not go in the data direction, but because everyone has like their own preferences, right? Like someone may say that like I want to be a front end developer, I want to be a back end developer, right? Or I want to be a machine learning engineer, right? So ultimately machine learning comes under your data systems as well, right? So these are the things that broadly you need to learn. Language stack, any language stack you can learn, but Python is a preferred one, right? Spark is computation framework which you need to learn. SQL definitely is important because as part of data ecosystem, you will work on variety of the relational databases or like warehouse systems where SQL is the primary language, right? So that also you need to focus on. Data warehousing, data mart, you need to understand how this there is a difference between data mart and data warehousing. Like data warehouse is basically, right, is centralized layer, right, like or like place where you kept all different departments data in the single place. Data mart is like isolated department, right? Suppose HR department, finance department, or like other departments, right, like will have their own data systems managed in the data marts. Data ingestions you need to learn, right, like how the historical load need to happen, how the incremental load happen, what are the different tools that you need to learn, right? Like these are the popular tools that I have just mentioned here. Probably you can just read out those topics. Data processing system anyway, right? Like I will cover this. I have intentionally, right, like rounded it here. I will focus more on live demo on this particular part, right? So Databricks is one of the crucial part that I will majorly focus on. Data governance, data quality, all of these things you need to learn because it is not just about ingesting the data or like processing the data. It is about quality of the data, right? It may happen that like you have wrong data in the, you can say that like whatever data that you have pulled. Most of the times I have seen that the front end applications will not have like proper validation. So suppose there is one of the company, right, like and they have the front end application where they are we can say, right, like enrolling the you can say people, right, on the particular platform, right, and they are not validating the mobile number. Now, if suppose I am not validating the mobile number, ultimately, right, like user can put any anonymous number, right? Like I can put 1 2 3 4 5 6 7 8 9 like that, right? So that particular data quality you need to manage. You need to remove those records because unnecessarily you cannot keep that record and you cannot derive any insights out of it, right? So all of these particular things you need to manage. Data cataloging is crucial part because once you have each data ecosystem setup, you have to, you can say that like where and all your data tables are residing in, right? Like because business users will not understand your technical terminology, they will just understand where is my data, right, and how I can consume. So for them you need to create a catalog saying that like this is the process where you just go and get the data and then process it and then read it and you generate your report, right? So all of this need to be considered documented. Consumption could happen on, you can say, any of the BI system like Power BI, Tableau, or any of the, you can say, visualization tool like ClickView is there, ClickX is there, right? Or you can say there is other player as well, Redash is also there, right? Or you can say that like I can create my own front end application which will basically consume this data point for the end users, right? So that could also be possible. Automation is important because whatever pipelines that you will create as part of data engineering or like machine learning pipelines or like DevOps pipeline, you need to automate that end to end, right? And then system architecture definitely it is important, but it can be come as part of, you can say, once you have like proper experience, you can work on this pillar. So this particular part you can ignore for now, but it is crucial part as and when you go and get like more experience on the data sector. So so there is some sample architecture that I have just kept it here. So I will just like brief you about this architecture and then probably uh, we will go in the demo, right? So as I mentioned, right, so ingestion is the first part, definitely, right? Like so whatever data that you have to ingest it from the variety of the different sources. Processing is another layer where you process the data and then transform in such a way that like on top of that you can find the insights, right? Serve is basically, right, like another layer where you connect your process data to the machine learning or like Kubernetes layer where you can deploy your application, and for machine learning for creating your models, right? So you can create a training data set, testing data set, and you can create a model out of it, right? Another could be, right, like whatever data that you have transformed right here, you can directly load that data to the Power BI for the reporting purpose. So process data goes in two directions, right? One is basically for machine learning, another could be, you can say, reporting, right? Now what this event hub data factory means, right? So event hub is basically pulling the data from the your streaming analytics sources, right, which I mentioned, like nuclear power plant, or you can say that like real time operating system. This can pull your data in the real time. Databricks can process that data in the real time mode, right? Data factories majorly look for the batch processing system, right, where you pull the data from particular sources. So data factory has around 50 plus odd connectors. You can connect to the SAP, you can connect to Salesforce, you can connect to any REST API, and then you can get that particular data, pull, and then store it on the as a storage layer, right? Once you store it, that stored data you can again, right, like pull it in the as a Databricks, process it, and then sanitize it, right? Sanitize means whatever data that you pull, right, ultimately, as I mentioned, it like will be raw, so it will not have any meaning. So it is bronze layer. We generally call it as like bronze data, right? Now we enrich that particular data system by processing, right? So we process that data, we write some logics, we code it, and then we transform it in such a way that like it will be properly useful, right? It will be a silver data, right? So next one will be silver, where it is more, you can say, curated or like transformed data. Now, on top of silver data, right? So you need to aggregate the data system, right? So it will say that like your gold data. Now let's consider it like the example. A bronze data could be, you can say, your everyone's marks, right? So you have university mark list. So we are getting, you can say, data from a university, and then you are loading it to the bronze, right? Now there could be, you can say, chances that like someone has not given exam, right? So there will be null value in the particular record, so you will remove that record. You will sanitize the data, and then you will load it to the silver layer. So silver layer again will hold the same data but with good quality. Now, suppose I need to build a dashboard for the principal, saying that like, what is my percentage? How much percentage students, right, like got passed, and they just have to look into, you can say, higher level numbers. They don't want to see, right, like what SSV has got marked in, you can say, subjects, right, like, or who, what Sagar got, right, in a particular subject, right. Rather than that, they want what is the percentage of the, you can say, right, like success ratio. That is your goal data, where you just create a data system in the aggregate layer, saying that like for this particular batch, suppose 23-24 batch, this is my, you can say, right, like engineering, like computer science, and this is my, you can say, percentage, 99 percentage folks, or you can say students got passed, right. So that's what actually your goal data. So that comes under your analytics again, and it will showcase on your Power BI, right. So business users will not get the data of the silver layer. They will not worry about what each person has got marked, right? So they will not worry about that part. They will be more focused towards what is the aggregated number, like what is my revenue, what is my profit, what is my, you can say, like how much I am getting, you can say it like sales from each of the person, right? Suppose I am transacting from the Amazon, and then daily I am purchasing something, right? Then I am a loyal customer for Amazon, right? Then that type of information that they actually get a pattern from your data system, right? So this is your gold data. And Power BI is ultimately for reporting. As I mentioned, warehouse you need to definitely build, where you load all this silver and gold data. Bronze data we will not load, but silver and gold data we load to the analytics system, which is your warehouse, which can be, you can say, used by the business analyst. So there is another type of customer, which is basically rather than principal. Suppose Dr. Prashkanza, they want to, you can say, see what is the, we can say, right, like where actually students are lagging, right? So they can write a query, and then they can get a result, right? So for them, actually, we create a, we can say, silver tables on the warehouse system, where they can query by their own, then they can create their own reporting, right? That is another thing. Now, as I mentioned, right, like your data cataloging and all the other pillars, right, that also we need to manage. So Azure Purview is for your data cataloging purpose, DevOps is for your CI/CD management, where, because if you see, right, we generally, right, like whenever we code to the, you can say, customer ecosystem, we create three platforms. One is development platform, second one is a quality assurance platform, and third one is a production ecosystem, right? So all of these things need to be tied to each other. So whatever code that I push to the development branch, it should get automatically published based on the approval, and then based on the quality checks to the production ecosystem, right? So all things need to be managed from the Azure DevOps. Keyword is for the secret management, like suppose I'm connecting to the Databricks, so Databricks provide their own PAT tokens, which is access token, right? So that access token, I cannot use the hard coded way in the code, right? So I need to put that in some place in the keyword, where I can pull that from the keyword, which is a secure place, and then I can use it, right? Active Directory for the user and groups management, monitoring, and cost management, right? So all of these things need to be handled. So this is sample architecture. It will change based on like how the problem statement that you have, and what actually you're trying to solve, right? So it deeper, but majority of the times these are the things that we generally focus. These are the architecture component. I have just given details about each and every pillar, so you can read out this thing. I will send this PPT to you guys. These are the comparisons of the services. So if you see, right, as I mentioned, right, like there are three major pillars of the cloud, like AWS, Azure, and GCP. Today I will show Azure, how the cloud looks like, and then basis on that, like you can compare it, like what actually, right, like means for the virtual machine in the AWS. So it is compute engine in the GCP. It is elastic compute cloud in the AWS, right? So it is, you can say, like similar pattern, just namings are different. Then next one is a processing engine, right? So as I mentioned earlier, right, so the 70 to 80% of the workload, right, you need to manage it through processing layer, right, because that is a crucial part. So there are plenty of the tools are currently available in the, you can say, market. These are all SaaS product where you can just code and then uh, get insights on top of it, right? So insights is not just about, you can say, getting some report, right? It is about how you code, right? For a data engineer, data scientist, the important part is basically how you write a code in the efficient way, right? How data structure you're handling, right? So I will give one assignment at the end of this, you can say, session. And then probably you can solve it on your home and then just send it to my mail ID. I will just check it. I will revert to you on that mail as well, right? So I just want to see, right, like how you are thinking, right, like with respect to data structure concern, right, as part of data sector. So these are the different processing tools that currently are in the market. Databricks is the biggest player, which has like around $35 billion revenue in the market. Snowflake is another one which has like $56 billion in the market cap as total market cap of this data analytics concern. BigQuery is currently eating up some space between this Snowflake and Databricks because most of the companies are now moving to the, you can say, utilizing Google BigQuery as, you can say, processing layer. Kafka is for your, you can say, data ingestion as a streaming, right? You might have heard about Confluent as one of the company who is managing this Apache Kafka as a product. ESD Insight is like Microsoft product for the Hadoop management. So you can see, right, like there's elephant. So this is symbol for your, you can say, Hadoop. CloudProc is another, you can say, service similar to ESD Insight on the Google Cloud. Amazon EMR is again, right, like Hadoop MapReduce concept, like they call it as like elastic MapReduce. So it is similar to, again, like your ESD Insight like on the Azure, but it is on Amazon. And then Azure Flink is for, you can say, both your batch processing system and your, you can say, streaming kind of processing layer, right? So all of these things we can utilize based on what is your need, what is your challenges, and what data solution that you need to derive. Majority of the time I have seen it, like Databricks and Snowflake is taking up the market. We generally work on batch operating system. There are really limited product who works on like, as a streaming kind of software. You need to utilize Apache Kafka and Apache Flink. So you can probably, right, like have understanding on these two layers as a primary object, like Databricks and Snowflake. Now there is live demo. So I will just go to, I will just show you, right, like how the cloud looks like. So if I just bring my screen here. So this is website for your, you can say, Microsoft Azure. Okay, so they have portal.azure.com. Similar way, right? Like you have AWS portal as well, and then GCP portal as well, right? So this is how actually your cloud platform look like, right? So I will just, you can say, go through all this concept first. If you click here, right, like it will show you what are the different favorite services. See, it is my personal account. I can create any of this particular thing, right? Like I can create a virtual machine, I can provision one SQL database, and then I can work on that, right? So this is how you can procure the systems, right? You have a dashboard to just monitor how your cost is fluctuating, and then whom ultimately, right? If I just click on the all services, it will show, right, like all the 2000 plus services which I mentioned, so that you can just look into, right? Now, whenever you come to the Microsoft Azure first page, definitely first thing is that you need to create a subscription, right? So subscription is nothing but, as I mentioned, right, like it is a pay as you go model. So whatever you utilize, you need to pay for that, right? So if suppose I just go to this, I need to connect my billing account, right? So suppose I need to connect my credit card or like debit card to this account, saying that whatever charge that I will get, it will basically deduct it from my particular bank account, right? So everything will be managed from this pay as you go model, right? So it will have like all the analytics, how the billing has been happened, what is the invoice, so how where and all like costs are getting utilized, right? So if I just go to the cost analysis for this month, so I guess like this month I just created one Postgre database and then I utilized that for some 1 hour and then I just decommissioned that, right? So you will see right for that particular 1 hour what is my cost, right? And prior to that month also, right, like I have some other cost which we can just switch it between like this invoice, right? So this is what is my current cost, right? Like so I just utilize this for 1 hour or like half an hour, I guess. So for that half hour, right, like it is like around 8 rupees, right? So what particular service that I have provisioned, it is a zero database for Postgres server, right? So this particular server I have provisioned on my this subscription and then I utilized it for some time, right? Now if I just go back, so first thing is basically your subscription. So inside to that subscription, you need to create a resource group. So what resource group means, basically it is a collection of the services, right? So it is a grouping. So suppose I want to create virtual machine, I need to create a storage account, I need to create Postgre database or like SQL server. I can collect all those things in particular one resource group. So it is a logical grouping of the resources, right? And then I can create a resources ultimately here, right? So if I just go back and then I will show you the services. So so there are different types of services, like around 2000 plus services that Microsoft provide, like with the different pillars to it. So AI and machine learning, these are the different 22 services that you can provision, like computer vision, you can provision that, you can service bot, you can create your own, you can say chatbot, face recognition applications, cognitive search. So suppose you want to build your own search engine, you can use cognitive search capability. Analytics, if you see, right, like today we are majorly focusing on this part. You can see like Databricks is here, which is one of the biggest data processing system where you can you know, you can say procure this Databricks and then you can work on and then write the code on top of it, right? Then there is a compute, which is basically right like your virtual machines and then all the other things, right, where you can group the virtual machines, which we generally call as like virtual machine grouping set, right? So there are availability set and then machine scale set, right? So you can create a multiple virtual machines in the cluster, right? That is also possible. So this is what actually your can say, right, like services look like. Now let's consider it like I want to just provision the virtual machine. So in the traditional way, right, suppose I have my own data center, then I will send the request to, you can say, project manager, saying that like this is what I want, and then I need this configuration virtual machine. They will send that particular, you can say, right, like invoice or like the PO order, right, purchase order to, you can say, your procurement team. They will procure that particular virtual machine and then you will utilize that, right? But here it is a little bit different. You will just click on this thing, you will say that like Azure, you want to create Azure virtual machine, and then as I mentioned, right, like you have multiple configuration options, right? So ultimately, right, like you need to select which subscription and which resource group. So suppose I'm just selecting this thing, you can give the name here, in which region actually you need to set, right? So as I mentioned, you have multiple regions. So I can say that like I want to set up it in the East US, right? So it will basically create this particular virtual machine in the East US region, and then I will get connectivity from directly from the East US, right? Now image is another part where you can say that like whether I want Ubuntu system or I want Windows systems or anything, right? So there are plenty of the options available, right? It is not restrictive to particular operating system, so you can choose any of the operating system. So it is that much simple, right? So you have to just click and then you have to get that provision, right? So it is that much easy, right? So these are the different operating system it provide. You can just select and then use that. So suppose I am just selecting this Ubuntu system. Now I just go back here in the virtual machine. Now, basis on this particular operating system, again, you need to select which type of virtual machine architecture that you want to select, right? Like there are two types of like ARM 64 and then x64, right? So generally x64 we use. There is x34, 32 as well, right? Like available, which basically you just 32 bits of your RAM, right? So that also you can choose. Now, once you select the operating system, again, right, like it comes as a size. So as I mentioned, right, like suppose I want to upscale and downscale, right? So that also can be possible. So if I just say that like see all sizes, you will see, right, like these are the different sizes that I have, right? It is just in the most used by the Azure. If I just disable that, I just go to the D series machine. These are the options that I have, right? Which has this many, you can say RAM, 8 GB RAM. This is my disk size, what is the size. So based on your need, you can just select it. Okay, for that particular thing, you will see that what is the cost per month. You will just select it, and then you will go to the next page, right? And you set your username, passwords, your networking, disk management, and everything. Once you go and set all these pillars, right, it is just click next, next, next. You will go to, you can say, right, like your review and create button. You have to just say, right, like create option. That's it. So I guess like I have missed some parameter here, right? Like I need to set some virtual network and all these things I don't have currently available. But the concept is basically it is that much simple, right? Like you have to just click and then get the things provision on the fly, right? So once you provision it, you can utilize it from your local system, from the, you can say, right, like any of the Windows CP based system. You can connect to that virtual machine and then you can work on that. Okay, so this is how the Azure platform looks, right? Like, so in similar way, right, like you have Microsoft, you have AWS, you can say, right, like Amazon AWS as well, and then Google Cloud as well, right? So you can check that as well. Yeah, and you can create free account ultimately, right, like for all of these three clouds. I have exhausted my, you can say, free account. That's why I have created pay as you go model. But when you create a free subscription, you will get like 2 month free subscription trial, and then you can utilize all these services by free, right? So you need not to worry about like paying any penny, right, like for this services, the utilization. So you can just try that out. Now, I will just go to the, you can say, Databricks layer. So as I mentioned, right, like Databricks is one of the, you can say, your processing layer, right? So I will just send this particular link in this chat. Where is the chat option? Okay, I guess it is here. So you can just copy it and then keep it with you. You can create your free account for the Databricks here, and then for portal.azure also I will just give this link to you guys so that you can work on this part. Okay. Now, okay, I will just log into my account. Okay, so this is how the UI will look like, right? So it is a SaaS product. So as I mentioned, right, like so earlier we discussed about what are the different types of your cloud instance models, right? Like you have infrastructure as a service, you have, you can say, software as a service, platform as a service, and function as a service, right? So Databricks is basically your SaaS platform where you have everything up and running. So earlier, right, like when we used to work on, you can say, data analytics platform, we used to create our own clusters, like Hadoop cluster or like Spark cluster by our own in the labs, and then we used, we can say, run our code on that particular system, right? So now there is no need actually, right, like to do that part. You can just say that like what is the particular size of machine that you want, and then just procure that machine, right? So if I just go to the compute. Okay, so I can just say that like I want to create a compute. So these are the pillars that you majorly see, right? Like you have workspace where you code your things. You have data layer where your data will be resided. So whatever tables that you will create will ultimately come here in the, you can say, data sector, right? You have compute option where you say that like which type of machines that you need to create. So suppose I'm just creating it for demo here. Demo now push. Okay, so I will just say that like create. You will see that like it is using this particular runtime and then Scala version, and this is my Spark version it will use, right? So I am just selecting the standard one. Okay, once I say create, basically it will create me the machine for like 15 gigs RAM, and then it will have like two cores. This one DBU is basically your Databricks unit. Based on that, like I will get charges, like how much time I have consumed, and then I will get charged for this for that particular thing. Now, next thing comes, right? Like once you get like this cluster up and running, right? So it will show that like green symbol here. Currently, it is getting started. You will see that like total green symbol here, which is up and running. you can go to the libraries. So it was also a nightmare for us, right? Like when we were using the on-premises system, where we have to install the libraries, and you can say, right, like the library versions were getting conflicted, and then we face challenges, right? So for that as well. So here it is a little bit simple, right? Where you can just say that like you want to install some library, you say that like which type of library that you want to choose, whether it is a Python library or whether it is a Maven repository, which is your Scala or like Java based repository or anything, right? So you will just select that and then you will install, right? Suppose I can just say that here pandas, let's consider, right, which is majorly used package, and then I can say that like install, right? So that is the process. Rather than installing it here, I will just show you, right, like how that can be installed on the node, because coding way is important than you can say, right, like the UI perspective, right? So let this first get started. So it is currently, right, like availability zone is this one, US West zone. So you can say it is running. So cluster is up and running now. So if I just go to the workspace, you can see, right, like the my name will come here, and then whatever notebooks that I have written till now, right, like will be showcased here, right? So I have worked on all these details. Like I have created some DBT models, I have created some streaming solutions. All of these things can be visualized here. So you can just go to that code and then can check that particular part. Now, next thing is basically data, right? So first and foremost thing, basically you need to onboard the data. So for now, right, like I don't have the connection to the storage account, so I will just create the file here. So basis on like what I have in the local system, I will just, so just remember the steps, whatever assignment that I'm going to give you, right? Like you have to do same thing. Create your Databricks instance, go to data, and then create a table, right? So once you create on the table, just click on this drop files. Once you click on that, you will see, right, like there, this file actually I will share with you, hierarchy file. For now, I'm just loading the orders file here. So if I just say open, you will see, right, like it is giving me the path of that particular file. So I will just copy it. I will not say that like create the UI from the front end, right? I will not say that. I will go to the workspace. Here I will just click on this arrow. I will say that notebook. Okay, so I need to create a notebook. Notebook is nothing but you have to write your code. Okay. Now by default, if you see, right, like it is selecting the name as Python, right? So you can choose between these languages. So you can code it in the Python, you can write the code in SQL, you can write it in the Scala. So whatever language tag that you prefer, you can write it in this particular language layer. Right? So I will just say here my notebook name is notebook uh, demo orders. Okay, so this is how you can give the notebook name, right? Now as I mentioned, right, like even though you are using Python, you can switch the language tag. So suppose I want to use the shell script, right? So I can say that like shell and then pip install pandas. Okay, if I run this, it is getting connected to, you can say, demo Nagpur automatically. So which is my, you can say, cluster. So this is my compute environment. Now on top of this cluster, basically it will install the pandas library, right? So you can install as much as library, right? Like whatever you want. And in the shell script again, right? Like suppose I want to see, right, like what are the files that I have. So I can say that like ls. So this is my current directory files that I have. I have a Azure folder, which is basically connecting to my Azure ecosystem. I can say that like on the root level, what are the different files and folders that I have, right? So this is the pre-built suite that you will get whenever you create a Databricks cluster. Okay. Now next part is basically, suppose you have to write the Python code, right? So suppose I will say that like Python here, right? So you can ignore this Python as well, because by default language is Python, but it is good practice, right? Like to keep the language name here, right? Now I will utilize the same file path, right? So whatever file path that I have copied here, so I will utilize this file. I will read it in the Databricks, right? So I will first open that in the Excel sheet, so that like you guys will get idea how that looks like. Let's go to the CDT. Okay, so I have opened the orders. Okay, so this is how it will look. So this is my order file. Okay, so which basically has like what is the order ID, what particular customer has purchased that order, what is the SKU. So SKU is nothing but your stock keeping unit, the one which I mentioned earlier, right? Which is the product number. how much quantity that has been, you can say, procured, whether it is one or two, right? Which type of payment that they made, what is the amount that they paid, right? So it is just a sample data. Now, what I will do here, I will just read this particular data system here. So this is how you can write spark.read.format, and this format is CSV. So I will just say that CSV and then just load it. Okay, so load is basically this file you have to load. I will just do this path here, and then I will run it. So if you run shift enter, it will basically run against to this particular file, and then it will create a data frame on top of it, right? So I am not utilizing pandas now. Pandas is just for your showcase purpose, how you can install the packages, right? But I'm using the PySpark. Okay, PySpark is basically your Spark engine. So I will just give you one link here, which you can just refer, and then you can learn, right, like how the Spark works, right? So this is the total module of the PySpark. So these are the different methods, functions that you will get, right? So you can just study on that. It is similar to the SQL, just it has, you can say, like Python variant on top of it, right? So we'll just send it here in the chat. Okay, now I will go back here. So if I just see, right, like this data, suppose I want to display it, right? So I will just say that display, and it will basically, right, like visualize here itself, right, like on this particular plane, right? Now if you see, right, like I did one mistake, right? One is basically if I just go to the Excel sheet. So this is my Excel sheet. You can see, right, like first row is my header, where I have data starting with from record 2, right, not from record 1, right? So but by mistakenly, right, like it started with, you can say, right, it added that as a data part, right, like as a row, and then column name it has given by its own, right? So simply you can just say that like your options, and then you can say that it is header is true. So when you say that like header is true, basically it will say that you have specified header in your data frame, and it will move to the upper line of your data system, right? Now suppose, right, like this is one of the data frame, and then I want to, you can say, right, create a object, or you can say, right, like one of the variable on top of it. I can just say that like data frame, give a proper name like ordered ef, let's consider, and then just put your, as a line here, right? So it will basically create the order data frame, uh, order underscore df, right? So this is my data frame name now. So I can utilize this data frame for further investigation, and then you can say, right, like tune or like curate this data point basis on like the business need. Now if you see, right, like you can observe all these variables are, or like all these columns are of type string, right? So it has identified as a string, but ideally, right, like this number should be a type of number, right? So you need to change that to the integer, then and then only you can sum it up, right? Before doing that, right, like there is a concept of visualization, right? So suppose I want to create a visualization on the Databricks itself, right? And then I want to showcase that report to someone, right? Then what you can do is you can just say that like add this particular data frame as it to the dashboard. So I will just say that like add to the new dashboard. It will basically launch the new page. Databricks recently, you can say, purchased one of the company, which is Redash, and it basically, right, like where you can create your own dashboards. So suppose that like you can just scroll it like this, and this is what a data system that I'm just keeping on one of the my dashboards. So this is my name of the dashboard. So suppose sample order. Okay. So this is the name that I have given to a dashboard, right? So this is how you can create your dashboards. Now I will just go back here, and what I will do is I will try to create a visualization on top of it, right? So there is a plus button here, right? So I will just click on here. I will go to the visualization. It will open me the visualization editor. Now what I need to find out is basically for each customer, right? So for each customer, what are the uh, how much quantity, or like how much, you can say, a value, right, like they have given, right? So suppose I will select the customer id as my x, which is below. So if you see, right, like 1000, this 1 2 3 4, these are my customers, and then I want to find out the amount, right, like paid amount, right, like how much amount that they have paid for, right? And then my grouping ultimately will be happening on the this customer id, right? Now if you see here, right, like paid amount is the amount that, like, suppose I have paid, and then I need to ultimately find out what is the lifetime value, right, like that this customer has given to me. So suppose Rohit Power is the customer, what is the value that he has given? Suppose it could be 1,000, it could be 2,000, it could be 5,000, right? But if you see right here, it is just giving me count and count distinct. Okay, so what could be the reason why it is not giving me some option here? Anyone? So I want to find out sum, but it is not giving me, you can say, some option here. Why that is happening? Hello?
Because the value is not numbered.
Correct.
It's the
Correct. Correct. Great. So because it is not a number, it is a string. String always have like this two type of thing, right? Like you can just count the string or you can do a count distinct, right? You cannot sum the string. So that's correct answer. So I will just say no here because I want to find out sum, but it is not giving me sum, right? So what I will do now, I will just close it. Now on top of this particular data frame, suppose what is the particular column that I need to change? Paid amount, right? So what I will do here, I will just say that first in Python, and then I will say that like from PySpark dot SQL dot functions import. I'm just importing everything. Okay, so all these methods, so whatever link that I have given, so this is the module, right? PySpark dot SQL dot functions. So it has like all these different, you can say that like methods. So you can import that here as part of, you can say, your Python standard, and then I will just say star, right? Now what I need to do is I need to convert this particular column to integer, right? So I will just say that like this one dot with column. So it is basically, right, like it basically takes your column and then you can cast it, or you can say apply any of this function, right, like whichever I just mentioned here. You can just apply that method on top of that column in similar way, right, like you do a SQL coding, right? So in same way you can do it here, but just syntax are a little bit different, right? So I will just say that like with column, and then on same column actually I need to reflect the changes, not creating the another column, but I want to change to the same column, right? So I will just say like this one. Which column I need to refer is again same, and then I need to cast it to the integer. So this is what the syntax is, right? So once you create this thing, and if I just enlarge this thing, you can see, right, like my paid amount has been changed from string to integer, right? Now I can display this particular data frame again in the next line. I will just display and then run. Now, once you see this particular data, like you will see like this paid amount is again coming as like 900, but it is now current shifted to, you can say it like as a integer, not a, you can say, string. I can click on the plus button, and then I can say like visualization. I can select customer ID as my, you can say it like X column, which is at below. I can say it like my paid amount as you can say it like Y column. Now you can see it like suddenly once we change it, like all this up we can say it like aggregation functions came here, sum, count, and everything, right? So I will just say like sum. I will group it based on, you can say, customer ID, and then I will just say save. Once I save it, right, it basically create a visualization saying that like this particular customer actually, right, like has 2,050 rupees of the, you can say, uh, transaction, right? So this particular has like 1,000, here it is 475. So I can just visualize it, right? I can give name to this visualization saying that it is um, cost revenue by customer lifetime. So in total lifetime, right, like what is the revenue that customer has given, right? So it is lifetime. Okay. Now same visualization I again can add to my dashboard. So suppose if I just whatever that dashboard that I have created it. So if I just go here and say that like add to this dashboard, it will basically uh, add that to the dashboard. So if I just go here, you will see that automatically this visualization will come on the on this place, right? So you can just do this. You'll say that like this is my visualization. Now it's been added. So same like sample order is your visualization report name, right? Now let's consider, right, like I want to so this is like two-dimensional plot, right? So I want to find out how much quantity, right, that each individual has, you can say, right, like purchased. Now there are three pillars. One is customer, definitely the customer who purchased the product, right? So product has a quantity, right? So customer is associated to the product, and product has their own quantities, right? Because I can say that like I will purchase particular X product of quantity 2, right? Or I will choose this particular product as like quantity 1, right? Now there are three layers, right? So you need to visualize this data in different way, right? So it is not a two-dimensional graph. You need to plot it in the three-dimensional layer, right? So that also you can go to. You can just go to the visualization. Same thing again, right? So rather than bar chart, I will just go to the bubble chart, because bubble chart is majorly used for, you can say, showing the three-dimensional view, right? Where X and Y are already there, but bubble size specifies how much quantity, right? So that's how actually we can position it, right? So I will just select, right, like X as my customer ID, Y is my basically, right, like the product, you can say product ID, and then group by I'm doing a customer ID again, and then bubble size is basically on the quantity, okay, and then bubble size is suppose 10. So if you see the difference here, right? So this particular bubble size is little bit smaller than this bubble size, because this has like quantity as a 2, this has a quantity as 1, right? Same goes for here, right? Now what is the what what particular analytics that you can find from this thing? What you can think? What is the thought process? So suppose I have this graph and I want to find out some pattern, right? Saying that like I want to predict, or I want to create something, right, like which is a predictive analytics, or you can say that like some reporting layer, right? So what knowledge that I can give from this particular graph to the C-suite customer? Any answer?
The first customer and last customer used the product more times.
First and this one you mean,
Last
or this one?
sixth and
Okay,
seventh. Uh,
okay, that is one thing. Another, correct. So they have, you
we
can
can
say,
find
purchased product. Hmm.
we can find number of unique products bought per unique customer.
Number of products bought per unique, means you are saying, right, like this particular customer purchased this product and these are the two quantities, like that, right?
Yes,
Okay, that is yeah, that is also true. Another thing.
success of products.
Okay, so which particular product that you think, right, like is a success?
First and seventh.
no,
Okay,
second, last.
which one? This one and this one?
1 and 7.
1 and 7. Okay, okay, okay. So if you see, right, like you give correct answer, right? Like all these are, you can say, insights. So insights are never wrong, right? So whatever you told, everything is correct. Now there is a little bit catch here, right? So if you see the first product, right, 8,000, right? If you see the combination, right, like there is no product, right, like which is bought in combination. So suppose this is person one, right, who bought this particular product, and the same product has been purchased by product, we can say customer six, right? There is no other product, right, like who is in the similar rate. Like there is no interaction or like intersection between this product, right? So what analytics that I can bot is, suppose this particular customer number one is Rohit Pawar and this particular customer is, you can say, right, like XYZ, and both has purchased product 8,001, right? That means they follow the similar patterns. Means my behavior and then customer behavior of six is a little bit similar in some sort, right? And customer six has not purchased 8,002. So what I can do is I can create a recommendation engine saying that product 8,001 that you have purchased, but there is a similar product that you can like, right? Which is 8,002. Similar way the Amazon do, right? So when you purchase some product, automatically they will say that like similar product purchased by other persons, right? Same way. So you can do the analytics saying that this particular product you can purchase. So that's how actually you can create an analytical layer, or like you can say recommendation engine for this particular customer, so that they will notice this product, they will purchase it. Because if suppose these two customers are of like same behavior, ultimately they will purchase that product. Same goes for your movie. Because if suppose I'm giving rating to particular movie as 5 star, and suppose right like someone else also given like movie rating as 5 star, that means like me and that particular person follow same pattern. And then suppose I have not seen like another movie, but that person saw the next movie, then automatically I will get a recommendation saying that like you go and watch this movie because it is recommended for you, right? In similar way you can create the recommendation engine on top of this. So finding the insights right is a crucial part. So you will see the data in the different patterns. So you have to plot it in the different way, you have to analyze it, and then you need to get the proper knowledge out of it, right? So that you can take decisions on top of it, right? So that is the important part. So I will just save it. Now next comes, as you can say, right, like I just shown you the Python, and then you can say shell scripting part, right? But there is another magical concept came here, right? Like most of the developers will not know about like how to write code in Python, but they know how to write efficient code in SQL, right? So you can create a table as well of this particular data frame. So if I just go to this table, so this is my data frame actually, I can create a table on top of it. So if I just go to the data sector here, in the default database there is no table as such here, right? Like so I have not created any table per se. Now what I will do is, so basis on this particular data frame I will just create one table. Okay, so dot write, and then I will save as table. Okay, and then I will just say that it is under default database, and order is my table name. Okay, so order table. Once I write it, okay, so it will basically write this data to the data sector here. So you will see that table coming here, and then on top of that table you can write as much as SQL code as you want, right? So you can do the aggregations, you can do anything, and then on top of that again you can create a reporting which you can add to the your dashboard. Okay. So it is taking a little bit time basis on the computation size that we have. It is very limited size. So generally we create like you can say multi-node cluster rather than a single node cluster in the customer environment. So it is complete. If I just go to the data, you will see that like under default there is table called like order table. Now I will just say here like %SQL, and then I will just say that like select star from like your normal select query, right? So default dot order. So if I run this, actually it will show the same structure, right, as you have here. So now on top of this SQL statement, you can do anything. You can put a where conditions, you can do a having, group by, everything, right, ordered by, all the things you can do in the normal traditional way that you do, right? So this is the basic thing, right? Like it is too much basic, right? Like we cannot cover like a whole depth knowledge of the Databricks in this time, but this is little bit give you sensing that like how the things works on, you can say, cloud, and then how it is easy, right? Like rather than procuring the instances and then setting up the processing layer and then working on that, how it is easy, right? Like to just get the environment ready and then work on that particular part, right? So I will just go back to the my presentation, and then there is a challenge here, right? Like there is one assignment that I want to give to you is this one. Okay, so what I want is you have this particular data set, like employee data set, and then their manager data sets, right? So these are their employee IDs and these are the manager IDs, right? Now the assignment is basically you need to write a function which is like get parent, where we will just pass, you can say, one employee ID which is like this one, suppose 198 or like 200 or anything, right? And then I need to find out who is the two level of hierarchy for that particular person, like who is the third level of hierarchy to that person, right? Saying that suppose if I take the example for 200, right? So if suppose I want to find out the second level hierarchy of the 200 is, so 200 reports to 101, right? 101 reports to 100, right? That means second level of hierarchy for this particular 200 is 100. Okay, so that should be the expected answer. So you have to write a function a Python code whenever you get time, right? Like it is not hard and fast, but study on this thing, right? Like it is crucial part. Just write a function which will basically return me the number, right? Like to which hierarchy it is, right? It could be anything. So I can put 2, I can put 4, I can put 10, anything, right? So it should show me the level of hierarchy number for that particular employee. Now you can see, right, like there are some hyphens here. So that hyphens are nothing but they are the own parents. So they are top level parent, right? So 100 is basically your top level parent. They don't have any parent again to that. So that means they could be a CEO of the company or like founder of the company, right? So for them, you need not to worry about showing any parent. So it will be, you can say, you can just print no parent for that particular person, right? But for others, if I just put the numbers of the employee ID and then their hierarchy number, then it should return me the, you can say, the parent, you can say parent employee ID. You got the point?
Yes, sir.
Okay, perfect. You can just, I will send this particular PPT with you guys. What you can do is, once you go here, right, you can just uh, double click on this. It will showcase the data in the, you can say, Excel sheet format. Just copy it, put it in the Excel sheet as a CSV, and then start, you can say, like your Databricks cluster and write the Python code there. Okay, perfect. Now I will just move to the next section, is which is a Q&A. So I'm happy to take any questions and answers. I will give those answers, right, like whatever you guys have, and then probably we can close to these questions.
In Google Colab, if you close the tab,
Mhm.
all the cells stops to run. Does the same happens in Databricks also?
Yes, correct. So Google Colab is like in similar way, right, like to the Jupyter Notebook. So it follows the Jupyter Notebook concept. So, but internally, right, like you have options, right? But Google Colab has like their own predefined clusters or like machines running in the shared workspaces. Here it is a little bit different, where you have to create your own instance of the, you can say, compute engine, and then you need to stop it. So stopping will happen automatically after a certain time. So generally, right, like when we create a production grade application, we give the ideal time as like 10 minutes. So after 10 minutes of the execution, right, like suppose at 10 minutes interval of time, if that cluster is ideal, automatically it will get shut down, so that like we will not get cost for that particular machine or like that particular compute service. But for the community edition, right, like that's why I intentionally sent you this community cloud Databricks. Whatever cluster that you will procure here, it will be free. So there is no charge associated to it. It is for learning purpose. So you can just create a cluster and then you can just try out how the Databricks works, right? So don't worry on, you can say, right, like you will charge on this particular compute. No, nothing will be charged here. It is free. It is community edition. Hope that answers.
Also, when we create an account, we need to give them credit cards, and we
No.
don't have that.
Yeah, so for Databricks, there is no need actually. For Azure, you need to specify the credit card or debit card. But it will just, you can say, charge minimal amount like 2 rupees. And you can give the debit card also. Prior to that, actually, earlier it used to have, you can say, credit card as a mandatory. But now they have, you can say, switch that strategy to, you can say, debit card as well. So you can give debit card detail as well. It will charge for 2 rupees. After 1 or 2 days, automatically that 2 rupees will be, you can say, recredited to your bank, and your free trial will get started. So once your free trial is end, right, no one will charge automatically, right, like basis on what resources that you have procured. They will send us formal notice saying that like your free trial has been, you can say, expired, and you have to go for like pay as you go model. Once you create a pay as you go subscription, then and only you will, you can say, get charged. So you have to go here like in the subscription. So I have like this particular like pay as you go model. Whenever you create your free account, you will have like free subscription. So here your subscription name will be free. So it will not be a pay as you go model. So if you see here, right, like it is loading up this screen. Yeah. So if you see, right, like this is pre-trial. So I have already exhausted this particular pre-trial thing. So I will not get this offer. Okay. But I can get, you can say it like pay as you go, and then Azure for student. If you have your university student account, like at the rate, sorry. Okay, so you can get free trial for now if you have like student account, right? Like you, if your college is giving your like student email address, specific student address, then you can take this advantage as well, like Azure for student.
In student email address, I have heard that you need .edu one, but we have got .ac.in.
Probably that we need to check actually, but I guess it takes that. I have not checked that list, but we can sync up probably. You can just try out with your student account. If there are any issues, right, you can just mail me. We can work together on it. But try
Okay,
out that part. Okay.
okay, thank you.
Yeah.
How do we contact you with the assignment submissions?
Yeah, I will give that details actually in the next. I can say it like my contact sharing page. Probably you can connect me on all these channels. This is my contact number, email address, and then LinkedIn profile. You can connect me on all these platforms, and I'm happy to, you can say, help you guys there.
Sir, how do we procure data in such structured formats for practicing?
Okay, so there are plenty of platforms available. So the biggest platform is Kaggle.com. So you can just go to the Kaggle.com, which is like one of the biggest data community sector, where you will get like plenty of the data sets in different formats, right? Like it is not just specific to the, you can say, structured format, but you can get the unstructured and semi-structured data sets as well. So if you just go to the data sets, you can search with whatever data set that you want. So suppose if you want to work on, you can say, drug related part, or you can say the medicines that you can say, right, like vaccine companies are creating, right? So all these things you can get it here, and they have specified like which type of format it is, like whether it is CSV, whether it is a JSON or any other type of system, right? You have to just log in here, create a register. It is free again. You have to sign in and then get whatever data that you want to, you can say, procure, download it, work on it, and then publish their results. So it is one of the biggest data platform, I would say, right? Like where all the community members of the data science, data engineering, and data visualizations comes here, and then they create their own, you can say, right, like data sets and then their notebooks. So probably this will help. I will just paste this in the chat. Probably you guys can copy this thing as well. Yeah. Any other question?
Mm, Um, uh, my question is
Mhm.
actually if we accidentally get any services we
Mhm, mhm,
cloud computing we don't want, did we still
mhm.
get amount of bill on that?
Yes, yes, but it is not related to, you can say, right, like to the pre-subscription, right? So you guys ultimately will create a pre-subscription, right? So generally, what I follow is, as I have, you can say, pay-as-you-go model, I will be more, you can say, right, like clear on it, like whatever things that I am provisioning. Suppose I have provisioned virtual machine or like Postgre database, right? Once my work is done and then my testing is done, right, or all the things that I have to work out on that particular service, I will decommission that immediately. Okay, I will not keep that running. For pre-trial, don't worry on that part, because even though it is running 24/7, you will not get charged. There are, you can say, plenty of the services will get free in the pre-subscription. So if you just go to the pre-services, these are the service that you can procure for 12 months. Okay, so you will not get charged for this any way, right? But make sure that whatever credit card detail that you provide, right, or like once you, but generally, right, like follow the practice saying that like once your work is done, just decommission that resource. That is good practice. Because we are not an organization. For organization, it doesn't matter, right? Like if suppose they get charged for daily basis, they will not worry about that, because their business is basically, right, like holding on that part, right? But for us, it is basically important. Make sure whenever you create anything, try out, work on that, decommission immediately. Okay, and if you go to the pay as you go model, more careful. You need to be a more careful, because if suppose, right, like I fortunately or like unfortunately I put this virtual machine up and running, and then I forgot to, you can say, right, like stop it, I will get charged. So on my monthly invoice page, right, so if you go here, so this is my invoice. and these are the payment methods. So if I just go to the payment method, my billing date is 24th. Automatically on that particular day, right, my billing will happen. So there is no, you can say, right, rebate. So you cannot claim that again, right? So please be careful whenever you procure any services, and decommission it immediately once your work is done. And even though, right, like after some time you want to again try that out, right, then again provision it, again utilize it, decommission it, right, but don't keep it running 24 by 7. That is first part, because this is, you can say, it's a learning, uh, for self learning purpose, right? So don't make that as, you can say, like 24 by 7. Okay, I guess hope that that answers. It is the biggest question actually, because I have seen same thing, right? Like one of my colleague actually, like he started the AWS subscription, and unfortunately, right, like he didn't stop the services, and he forgot like he had AWS subscription. After 1 year, actually, he got the charge for $10,000, and it was, you can say, right, like a nightmare to connect with their support team and then get that resolved, right? It is a little bit complex part. So make sure, right, like when you provision it, just and decommission those services, don't keep those up and running. Okay, anyone else? I guess silence means everyone are good now. Okay.
Okay, so I guess everyone is done with the questions.
Okay, perfect.
Thank you, sir. So now,
Great.
as we draw the curtains on this enlightening and insightful session on cloud data analytics, I would like to extend my heartfelt gratitude to all of you for joining us today. It has been a truly enriching experience, and I hope you leave this session with a wealth of knowledge and inspiration. First and foremost, I would like to express our sincere appreciation to our esteemed chief guest, Mr. Rohit Pawar, sir. Your expertise and wisdom has illuminated this webinar, providing us with valuable insights into the world of cloud data analytics. We are genuinely grateful for your time, your knowledge, and your dedication to this advancing field. A special thank you to our audience who actively participated. Your engagement, thoughtful questions, and enthusiasm has made this session a truly interactive and dynamic one. In closing, I want to emphasize that learning is a continuous journey, and today's session has been a significant milestone on that path. We encourage you to carry forward the insights gained here and continue to explore and innovate in the field of cloud data analytics. Once again, thank you all for your participation and contribution. We look forward to seeing you at future events and we wish you all continued success in your endeavors. Thank you and goodbye.
Thanks all, and all the best for your interviews. It's like it will be last year, right, for you guys. So all the best for that, and excel in your career, right? I would say that, like, don't restrict just to, you can say, cloud data analytics, but try to, you can say, see what you guys are actually interested in, right? So don't be restrictive just on, you can say, cloud data analytics, but see other horizons as well, right? Like, because there are other plenty items as well, right, like, to learn. So just grab that as well, right? Like, and then excel in your, you can say, right, career journey ahead. So all the best for everyone, and then thanks for giving me chance here, right, like, to present in front of you. Thanks again to Dr. Prashant sir, and then everyone, audience, right, like, for patiently listening to me for this 2 hours journey. So thanks again. You can contact me on this particular details. I will send this presentation to Sangeet, I guess, and then probably he will circulate with you. Thanks.
Thank you. Thanks.
Rohit.
Yeah,
Okay. Okay, I will call you for more seminars. Okay, in future,
yeah,
you
sure.
be touch with it. My
Yes,
student will call you regarding some project based on this big data analytics and cloud
definitely,
analytics. Okay.
definitely. Yes, I will be happy to help them actually. No problem.
Okay. Thank you for joining with us and give some insights on that big data analytics and cloud analytics.
Sure, sure.
So
Thanks.
my student will definitely work on this area in future. for their
Yes.
academic projects. Okay. Okay.
Yeah.
Thank you, dear.
Yes, this is good. Actually, I would say that like this is a good platform actually to learn, and then there are many parts that you can. I will just give you can say I will just take 2 minutes actually here, just to give a little bit idea on it, like what project that you guys can work on. Simple could be you can say that like creating house rate prediction algorithm, right? So you can just get the data set from your Kaggle and then create a algorithm, right? Like machine learning algorithm as a regression model. Just deploy that model on the Kubernetes or any of the deployment service as a endpoint, and then use that as a front end application, right? So suppose I have one front end application where I need to put like some features like saying that in which locality I'm living in, and then what is the carpet area, what is the built up area, and then how we can say develop this particular area is right. So all these will be the input on your front end application. Once you say submit, right, automatically your model will get utilized as a backend. You can say weights for that machine learning weights. It will enforce on your inputs data set and it will give the target variable. So this could be, you can say, simple machine learning algorithm that you can create and then deploy it on the, you can say, front end application. So that could be one of the project. Another could be, you can say, much more in the, you can say, like deep learning fashion, where you can use OpenAI capability, because currently OpenAI is, you can say, getting more engagement from the customer as ChatGPT, right? Like you might have heard on, right? ChatGPT in the backend using OpenAI as a library. So you can utilize that library as well, right? Like for all the different types of machine learning and data centric applications. Like you can create your own search engine, because OpenAI does their own embeddings of the vectors. So you can search on that particular vectors and then get the result as a search engine. So in similar way, right, like your Google search engine works. So ranking and everything, right, like you can build on by your own, right, on top of that. So these are the different things that you can work on. Then another could be, you can say, your live stream data you can take from the video based data systems, and then you can just analyze it, like where in particular which section, right, like there is a human, in which particular section there is a car, right, in which particular section there is a house, right. So it is a kind of, you can say, like video augmentation system where you have to find out the objects on the video, right, like, or the images. That is also one of the, you can say, detection algorithm that you guys can work on. I will share one of the link also, right, like here probably you can that will help you guys, right, like to get more details. Papers with code. So there is one website called Papers with Code, which basically is a research papers. So you will get like all the research papers and then their logic of the code, right? So this is the biggest platform, right? Like where you can just go and then see, right? Like what are the different types of like research papers on the data engineering or like data machine learning, right? Like are currently available, and then implement those papers as part of your project. So that is also helpful. I guess, yeah, that will help. Hope that helps to you guys.
Yes, sure. That will surely
Okay.
help us.
Perfect. Okay, great. And whenever you guys want to call me, you can call me, you can mail me, you can connect me on LinkedIn, and I'm happy to help you, right, like in your career journey. Anyway, thanks again.
Sure. Thank you so much, sir.
Thanks. Bye bye.